The sensor saw, the model decided, the result arrived. That same week, SpaceX and XAI filed for the largest initial public offering in history, listing launch, constellation, and frontier AI inference under a single entity valued near $2 trillion. Two architectures. One closes the inference loop before the ground can see it. The other prices your dependence at $2 trillion. New Zealand's GBSI Act compliance deadline is 29 July. It describes what satellite broadband operators must do. It says nothing about an orbital AI agent that completes 80% of its decisions without asking permission from the ground. When your satellite makes a decision before you can ask it a question, which governance framework catches the inference loop?
Let's get into it.
In 1963, the United States launched Telstar 2, the world's first commercial communication satellite. It relayed a single television broadcast across the Atlantic. The entire transaction between the satellite and the ground was visible, auditable, and governed. This is the Hamburger Report. I'm Andreas Hamburger, Enterprise Architect and Board Governance Specialist, Wellington. Two events in the first half of 2026 confirmed that the orbital AI architecture Telstar made possible has split into two fundamentally different models. One is a public company valued at nearly $2 trillion, controlling the rocket, the constellation, and the AI inference stack. The other is a Jetson Orin processor orbiting above Alice Springs, completing 80% of its inference tasks without transmitting a single processing request to the ground. The split is not a story about technology. It is a story about who controls the loop between the sensor and the decision, and whether you can ask a governance question of that loop and receive a technically verifiable answer. On 20 May 2026, SpaceX filed the largest initial public offering in history. The S1, lodged with the United States Securities and Exchange Commission, describes a single entity controlling the rockets that reach orbit, the constellation of more than 6,000 satellites carrying data across it, and the Grok lineage AI models inferencing on top of it. Target valuation, $1.75 trillion to $2 trillion. The SpaceX and XAI merger closed in February 2026 as an all-stock transaction. Revenue for 2025 was approximately $16 billion. Net loss post-XAI integration, approximately $4.9 billion. The IPO was not a distress signal. At $1.75 to $2 trillion, it was a capital markets verdict on what vertical integration of launch, connectivity, and frontier AI inference in a single entity is worth. Morgan Stanley's framing, which I cited in Space Mafia, remains the most precise. The companies that master orbital infrastructure will define the next era of computing. Those that do not will be tenants, not owners. The SpaceX and XAI S1 is the legal formalization of that sentence. By the time this episode publishes, the IPO has completed. One entity now holds the title to the rocket, the satellite, and the model. Every organization that routes data through Starlink, builds applications on Grok, or depends on SpaceX for launch access is, in the precise meaning of that word, a tenant. 55 days before the S1 filing, on 25 March 2026, a Planet Labs satellite called Pelican 4 completed approximately 80% of its inference tasks over Alice Springs without transmitting a single processing request to the ground. The inference ran on a Jetson Orin processor on board the spacecraft. The sensor saw, the model decided, the result arrived. This is not incremental. Satellite intelligence has until very recently operated on a collect and transmit model. The sensor collects, the data transmits to a ground station. The processing happens on terrestrial infrastructure, and the result returns uplink. Each step adds latency. Each step adds a ground-based dependency. Each step creates a point where a governance framework can in principle operate. Pelican 4 short circuits that model for the majority of its processing tasks. The Lethal by Design series, which launches on this channel on 26 June, examines exactly this failure mode. The governance frameworks that assume humans can intervene in a decision loop that has already closed without them. Pelican 4 is the orbital version of that problem. The series is in the description. From an architecture standpoint, Pelican 4 is the first commercial confirmation that the Heaven Vector, the distributed, task-specific, open, verifiable edge inference pathway described in Space Mafia, is operationally viable at scale. The temptation on reading both stories together is to treat them as variations on the same theme: AI going to space, governance struggling to follow. That framing is wrong, and the mistake it embeds is consequential. The two announcements are not increments of the same story. They are the structural endpoints of two different architectural philosophies, creating two entirely different categories of governance problem. The SpaceX and XI problem is a concentration problem. One entity controls the launch vehicle, the constellation, and the inference model. The sovereignty question is, what happens when the landlord decides the lease terms no longer suit you? The capital markets answer, at 1.75 to 2 trillion, is that the landlord is very large indeed. The Pelican 4 problem is a jurisdiction problem. Inference completing in orbit without a ground uplink means the processing loop closes in a space where no existing regulatory framework has binding reach. The GBSI Act establishes compliance obligations for satellite broadband internet service operators delivering services in New Zealand. Compliance deadlines are 29 July 2026. The Act describes what operators must do. It does not describe what an orbital AI inference agent, completing 80% of its tasks without transmitting to any ground station, must do, because that architecture did not exist as a commercial product when the Act was drafted. New Zealand organizations assessing their orbital AI exposure now face two categories of dependency, not one. The first is the hyperscaler concentration risk. Space Mafia identified in this series. The AWS Pacific concentration, that means a significant share of New Zealand government and enterprise workloads route through infrastructure controlled by a small number of entities. The SpaceX and XAI listing signals a comparable concentration crystallizing at orbital altitude. The second category is the edge inference dependency. Pelican 4 confirms. When inference completes in orbit without ground uplink, the data that arrives has already been processed by a model you did not train, on infrastructure you did not commission, in a jurisdiction you cannot audit. The sovereignty question is whether you can verify the reasoning and what recourse you have when you cannot. Against both risks, New Zealand has one sovereign alternative worth naming. Rocket Lab, headquartered in New Zealand and operating the Mahia Peninsula launch facility, is developing the Gauss platform for onboard satellite edge computing. A commercially successful Gauss platform would position Rocket Lab as an allied nation alternative to the SpaceX and XAI vertical stack. Which of your orbital AI suppliers can you ask a governance question of and receive a technically verifiable answer? The 3 clocks framework maps orbital AI development across 3 independent timelines: the industry clock, the regulatory clock, and the conflict clock. The industry clock has surged in the first half of 2026. Planet Pelican 4 is a confirmed commercial deployment. The SpaceX and XAI listing is a confirmed capital markets crystallization. Both events were watch items in prior sessions. Both are now promoted to active. The industry clock is ahead of every other clock in the framework. The regulatory clock is fixed at 29 July 2026 for the GBSI Act compliance deadline. That date does not move. The conflict clock has not registered a primary event in Space AI Monday until now. Pelican 4 changes that. Autonomous inference above Alice Springs closes the sensor-to-decision loop without ground visibility. The 5-country council, Agentic AI Guidance, co-authored by the National Cybersecurity Centre New Zealand, identifies autonomous agent inference in satellite systems as a Tier 1 concern. Pelican 4 confirms the capability. Class the guidance warns about now exists as a deployed commercial product. The conflict clock is active. Its primary reading is not aggression. It is the gap between what allied intelligence frameworks can see in an orbital inference loop and what completes before anyone on the ground looks. When Planet Pelican 4 completes 80% of its inference tasks without transmitting to Alice Springs or to any other ground station. The loop that closes in orbit is invisible to Allied intelligence assessment frameworks that depend on intercepting or monitoring data flows between the satellite and the ground. This is not a capability failure. It is a structural consequence of the edge inference architecture. The National Cybersecurity Centre, New Zealand, as co-author of the 5-Country Council Agentic Guidance, is part of the Allied Collective Assessment Infrastructure that evaluates orbital AI intent. When orbital AI inference completes without a ground uplink, that infrastructure's assessment of what the satellite decided and why is technically constrained. The constraint arises from the same architecture that Planet Labs announced publicly on 25 March 2026 for NZ Maritime Domain Awareness in its exclusive economic zone. The stakes are specific. Earth observation satellites completing inference in orbit without ground uplink can make decisions about what they have observed in New Zealand's EEZ before any allied or domestic intelligence framework sees the underlying data. That is an operational consequence of a confirmed commercial architecture. 2 orbital AI architectures are now confirmed as operational. One gives you a realistic chance of catching the inference loop. The other does not. The governance question is not which architecture you prefer, it is which one you can ask a question of.
That is the Hamburger Report for today. If this was useful, subscribe and hit the like button. It helps more professionals find the channel. You will find links to everything we covered in the description below. I am Andreas Hamburger, and I will see you tomorrow.
Like and subscribe.